time release that
So your lab exams are still being graded. We're going to get those graded this week, and then we'll give you back grade sheets next week in lab. Today we're going to go ahead and introduce assembly files in SolidWorks. So you've gotten really good at making parts in SolidWorks. Today we're going to start talking about how we can take those individual parts and put them together into a mechanism or an assembly file and tell SolidWorks how those different parts relate to one another. But first, there's two remaining tools in the Sketcher that we want to talk about, because we haven't covered them yet, but they are very important and very useful tools. One of them is called Sketch Picture. The other tool is called Sketch Block. Now, the Sketch Picture tool allows you to take a photograph or any other image file and actually import that image into a SolidWorks sketch so that you could just trace over it. Okay, so for example, if you were going to create a SolidWorks model of something like this mouse, some oddly shaped object, it would probably be easiest to just take photographs of this mouse from above, from the sides, from the front and the back, bring those photographs in on different sketch planes, and then just sketch some splines over the edges in the picture and produce a wireframe model that then you could use surfacing to produce the SolidWorks model. And for an oddly shaped object like this, that would probably be a lot easier, just tracing over a picture, than it would be to take a ruler and try to measure dimensions on this object and try to use just dimensional information to reproduce this shape. Right? So I'll show you how to use Sketch Picture in just a second. The other tool that we're talking about is Sketch Block. That allows you to take a sketch that you've created and save it in its own independent file. And you can then reuse that sketch block in your part over and over, or in different parts over and over. So this could be useful if, for example, you're working for a company, or maybe you own your own company, and you created a company logo in a sketch, and you want to put that logo into every part that you manufacture. Well, you could just save that sketch as a sketch block, and then you can bring it into all of your different parts very easily. And what's nice about sketch blocks is each time you insert a sketch block, SolidWorks lets you scale the sketch block to make it larger or smaller, and you can also specify an angle of rotation for that sketch block if you need to change its orientation. So to demonstrate those two tools, I'm going to use this airfoil as an example. So this is NACA 4415 airfoil. Now, when I tell you this is an airfoil and show you a picture of it, what is that actually? Because some people may not be familiar with what an airfoil is. So what is this?
cross-section of the airfoils.
Okay, it's a cross-section of the wing. Of the wing, exactly. This is an airplane. Okay, so the airplane is facing this way. The wing extends into and out of the screen lengthwise. We've spliced through the wing, and this is the cross-sectional shape of that airplane wing. Okay, so as the airplane is flying along this way, the airflow comes in, it passes over and under the wing, and that's what generates lift upward. There's a lot of different airfoils that have been standardized and defined. NACA 4415 is just one particular one, but there's many other airfoils that have different shapes. And they've been studied extensively in wind tunnel testing so that we know the aerodynamic performance of these different airfoils. So suppose that you've decided this is the airfoil shape that you want in your part. This has the aerodynamic characteristics that you need. You want to reproduce this shape in your SolidWorks model. The easiest way to do that would be to bring this in using the Sketch Picture tool and then just trace over it with a couple of splines. So, in SolidWorks, let's go ahead and start a new part. And I will start a new sketch. Doesn't matter what plane, I'll just pick the front plane. Okay, so to bring the picture in, you're going to go to the Tools menu, go to Sketch Tools, and then go down to Sketch Picture. So that's a command sequence you might want to write down, because that's easy to forget. Go to Tools, Sketch Tools, Sketch Picture. Tools, Sketch Picture. Click that button, and then that lets you browse to find the image file you want. So here's that PNG file. You can also bring in a bitmap or a JPEG or any other image file. So it brings that picture into your sketch. Now, one thing that I'll point out, just in case it's useful in certain circumstances, you can set the entire picture or portions of the picture to be transparent if you want. Like you could set the full image to be transparent if you wanted, if it was covering up something that you wanted to see, or you can make it partially transparent. Or, like if you just wanted to take this white background color and make that transparent, you can do a user-defined, select that white color and make that fully transparent or partially transparent, whatever you want to do. I'm not concerned about transparency right now. What I am concerned about is the size of this picture. Now, it comes in, any picture you bring in is going to come in at some random size. That depends on how many pixels are in the picture, how large it was when it was saved. You don't really know how big a picture is going to come into your SolidWorks part. And there's nothing that you can smart dimension on the picture because it's just a bunch of pixels. There's no sketch elements in this yet. So, what I would recommend you always do when you bring in a picture and you want to trace over it is go ahead and create for yourself a reference line using a center line with some known length. So I'm going to start a center line and just draw it horizontally and smart dimension that center line to be 1 inch. And then, so you can see the picture is much larger than that, but then I can double click the picture and I can just drag the corner to scale it down and make it about that size. So what I want to do, because I'm going to use this to create a sketch block, and as I mentioned earlier, we can scale a sketch block whenever we insert it to make it larger or smaller. So it's convenient to have this some unit length, like 1 inch. Because then if I want a 6-inch airfoil, I just multiply it by a scaling factor of 6. So you can just drag the picture to position it and to adjust its size until it matches up with the center line that you've created. And I'll just say that's good enough. Now, to make any kind of an airfoil shape, I would always recommend that you use a 3-point spline for the top and a 3-point spline on the bottom. Okay? And so I'm just going to start a spline. I'm going to click once at the trailing edge, then click at this highest point of the airfoil where it kind of flattens out there at the top. I'm going to put 1 point there, and then put the 3rd point right up here at the leading edge of the airfoil. Hit escape. That's my first spline. And then I'm going to start a new spline, and again, go from the trailing edge to the lowest part of the airfoil where it kind of flattens out there. And then connect back up to the leading edge of the airfoil, and that's my second spline. Now, manipulating these spline handles, where this airfoil flattened out on top, I want that spline handle to be horizontal. So I just make that constraint, and up here at the leading edge, I want that handle to be vertical. Vertical, there we go. And then for the lower spline, same thing. Where it flattens out at the bottom, I want that handle to be horizontal. And up at the leading edge, I want that handle to be vertical. And then, just by adjusting the angle and the magnitude of these remaining handles, you should be able to get a shape that very closely approximates the shape of that airfoil. And it takes just a little bit of playing around with it. With just a little bit of trial and error, you can get a shape that very closely approximates the shape of that airfoil. So let's say I've played with that long enough, I'm happy with the shape, that I've matched the picture close enough. What I want to do now is save this shape into a sketch block. So this is another command sequence that you'll want to write down. To create a sketch block, you go to the Tools menu, go down to Blocks, and then click Make. Tools, Blocks, Make will bring up this selection box where you choose what you want to put into the sketch block. So I'm just going to click the 2 splines. And you have the option of choosing an insertion point down here. The insertion point is optional, but it's a good idea. Okay, the insertion point is the point on the sketch that will follow your cursor around whenever you insert this into your new part. So, like if I want to make sure, if I know that I'm going to put this airfoil someplace and I want to snap the leading edge to a particular location, maybe at the origin or something, I would want to drag this insertion point right up there to the origin and just snap it, or right up to the leading edge, I mean. Just place the insertion point there. And go ahead and click the check mark. Okay, so that created the sketch block. And you see it now listed over here as block 1-1. And I will accept that sketch. Now, if the picture is in your way and you want to hide it, over here in the sketch 1, you've got the sketch picture 1, that's your picture. You can just right click on it and suppress it if you want that to go away. And then you're just left with the sketch itself. Now, if you want to save that sketch block to a disk, over here in the feature manager, just right click on it and say save block. And then you can choose a location. I'll just put it on the desktop, call it block1.sldblk, save that. Okay, and back on the desktop, here's the solid block part that I just created, or the sketch block. It's not a part. Okay, so back in SolidWorks, I've got my sketch block saved. I'm just going to go ahead and delete that file and start a brand new part to show you now how we can bring that sketch block in and do something with it in a new part. So I'm going to say start a new sketch on the right datum plane. Now to bring the sketch block in, we go to Tools, Blocks, and Insert. Click Tools, Blocks, Insert, and then browse to find the block that you want. So on the desktop, and I should be able to find block 1 right there. Say Open. And it follows my cursor around. Notice it's the insertion point that's following my cursor around. And if I want to snap that to the origin, I can easily just place that right there. Notice over here, this is where you can set a scaling factor if you want to make it larger or smaller, and a rotation angle. But I'll just click that one there and hit escape because I don't want a second one, and accept that sketch. Okay, so there I placed the sketch block. Let's do one more. Let me create a reference plane that's offset from the right datum plane, let's say 10 inches. And let me place that sketch block again on that plane, but we'll scale it this time. So I start a new sketch on that plane, do normal to it, and then go to Tools, Blocks, Insert. My block 1 is selected. This time let's go ahead and just scale it down. Let's make this one say 0.5, and maybe even let's rotate it. Let's give it like a 10-degree angle of incidence, and we'll just stick it right about there. Okay, and accept that. And we could dimension to that leading edge if I had a precise dimension that I wanted to locate that at. But so anyway, there's the 2 blocks that I placed. That's how easy it is to reuse sketch blocks, and you don't have to recreate these sketches over and over. Okay, so do you have any questions about creating or using sketch blocks or the sketch picture tool? Anything that we've seen so far? It's pretty straightforward once you know where those commands are located, that they really can make your work a lot easier, save you a lot of time. Okay, so let's get rid of that and start talking now about assemblies. So the first assembly that we're going to make this week is the Mars rover Curiosity, or based on the Mars rover Curiosity. I've given you all of the parts you need to create this assembly on D2L. So on D2L, we go to the content area of this course. For this week's lab, there's this Space Rover module, and you can click the Space Rover parts, download that, and I'm just going to save that to the desktop, spaceroverparts.zip. completed. Minimize that. Okay, so here is the space over parts zip file that I just created, or just downloaded. Just out of curiosity, how many of you have worked with zip files before? Okay, about half of you. What is a zip file?
Compressed versions file.
Okay, it's a compressed file, and so it takes files and makes the file size smaller, but it also does one other important thing, and that is allow you to take multiple different files and put them into one file archive, one file name. So, for example, if I double click on this zip file that I just downloaded, okay, you'll see it expands and there's 5 different part files in that one zip file. So the zip file is just a convenient way. Not only does it make the file size smaller, which, let's see if I can show all of this. Okay, so here's the original file size, here's the compressed size, and you can see the compression ratio there. It's making these about half as big as the original parts were by compressing them. But this also saves you from downloading 5 different part files from D2L. You only have to download one zip file. The important thing with a zip file, though, is you do not want to work directly with the compressed versions of the files. When you download the zip file, the first thing you want to do is uncompress it. So right-click on that zip file and choose this Extract All option. And you can choose a location. I'll just put it on the desktop. Let's just say Extract. And SOLIDWORKS goes through and uncompresses those files, and now gives me this space over parts file folder. If I double click on that, now we have the normal uncompressed versions of those files. And these are the ones that you actually want to work with. Now, I think if I go back to this zip folder and double click on it, SOLIDWORKS will actually try to open a compressed version of a file. So if these are the zip files. If I double click on this rover body solid part, okay, it gives me, this is good, at least it gives me a warning message. It says it's not available for write access. Now, if I click open it as read only, okay, it does go ahead and open it, but if you can see the file name up here, it tells you that it's read only. Even though it opened this file, do not work with the compressed versions of the files, okay? It causes all kinds of problems. Compressing the file is a little bit like encrypting it, because you're actually changing the bits of data, and that causes all kinds of problems for SOLIDWORKS. So the important point to make here is don't work with the zipped versions of the files. In fact, after you extract the files, I would encourage you just go ahead and take that zip file and delete it. Get rid of it, that way you don't accidentally pull a part out of it and mess up your whole assembly. Okay, so I've got the uncompressed versions of the files there, and in SOLIDWORKS we're ready now to start a new assembly. So we go to File, New, and for the first time we're going to choose an assembly document, say OK. And SOLIDWORKS opens up ready for you to bring the first component into your assembly. So you just browse for it. I'll find that folder with my parts, space over parts. Now, you want to put a little bit of thought into which component you bring in first, because that first component is kind of going to be the foundation of your assembly. All the other parts are going to be defined relative to that first component that you bring in. So for our rover part, what makes sense to be the first component we bring in? The body. This is kind of the center of the whole assembly, so let's bring that in first. So I'll choose rover body, and click open, and that's just following my cursor around now. Wherever I click, it's going to drop that part into the assembly, and there we go. It's just kind of fixed in space wherever I click. Now, notice in the model tree, your assembly file does have an assembly front plane, top plane, right plane, and an origin. And just like part files did, and now we've got this rover body solid part, which you can expand, and you can see all of the features of this part file. It's front plane, top plane, right plane, origin, And then you can see the individual features that made this part. You can expand those and see the individual sketches that were used to define those features. So we're just kind of nesting the parts inside this assembly file, and you still have all the part and sketches, all the features and sketches nested inside the part file. Now, rather than have this at some random location relative to the assembly reference datums, it's probably a good idea to go ahead and put this in a more logical position. So in assemblies, the way we tell SOLIDWORKS where something belongs or how it relates to the rest of the assembly is to use this Make button. Okay. Now right now, the body is just fixed wherever I clicked it. So to unfix it, I can right click and choose this command that says float, and now it's free. I can drag it anywhere I want. And now I can use the Make button to precisely position it relative to our assembly reference data. So when I click the Make button, this dialog box opens up. I'm simply going to click some feature on the component. It could be a face, a point, an axis, a data plane, anything on the component, and click something on the assembly model and tell SOLIDWORKS how those two entities relate to one another. So for example, I want to choose this top face of the rover body and choose the top data plane of the assembly file and tell SOLIDWORKS that those should be coincident. Okay? And then I click the green check mark to accept that constraint for that mate. And as a convenience, this box stays open so that I can just keep specifying additional mates. Because that really is the main operation you're doing in assemblies. You're just specifying one mate after another to relate these components to one another. But notice the different kinds of mates that you can make. You can make things coincident. You can make faces or planes parallel to one another, perpendicular, tangent, concentric. Concentric just means that two curved entities will have the same center point or the same axis. There's an option called lock. I would recommend that you never use the lock constraint, because that causes more problems than anything else. Avoid using the lock constraint. But you can also specify an offset distance or an offset angle. Those are very useful. Okay, so we've made it the top surface to the top data plane of our assembly. Let's go ahead and make the front surface of the body to the front data plane of the assembly. Make those coincident. And accept that. And then also, I want to take the mid-plane of this rover body, which, let's see, the top view. In the rover body, there was a, so let me expand this. Plane 1 was created for you as a convenience to be the mid-plane of this rover body. So I can take this plane 1 and made it to the right data plane of the assembly, make those coincident. So now my rover body is fixed in a logical location relative to the assembly references. And if I go to like a front view, that gives me a logical front view, a right view, and a top view. All give me views that make sense for this rover body. And now I'm ready to just start assembling additional components to the body. So to bring in more components, we click the Insert Component button. We browse to find the components we want. You can select multiple components at once by holding down the Control key. So I'll hold down Control and click Arm 1, Arm 2, and Part 2. Those are the three components I want to bring in. Click Open. And then as I click the mouse around here, it just places each one of those components sequentially. There's Arm 1, Arm 2, and Part 2. Okay, so they're just floating in space, but now I can specify how these components relate to the rover body. So I will turn on temporary axes so I can see the axes in each of these. Let's drag this down a little bit closer to where it belongs. So what I want to do first is put this arm onto this little knob that's sticking out from the rover body. So just go to Mates, and I can choose that axis and that axis in the little peg and make those coincident. Click the check mark, Okay, so those axes now are going to be coincident. And if I click and drag this, I can still change its rotation, and I can slide it back and forth, but I can't misalign those two axes. Those are always going to be coincident. So the other thing I want to do is make this face here coincident with the corresponding face, circular face of that knob. Now, notice that it kind of buried part of the arm inside the rover body, and it made those faces align facing the same direction. I actually wanted them to be mated facing the opposite directions. So to change the mate alignment, I still want them to be coincident, but I can change the mate alignment with these two options right down here. Just click the, SOLIDWORKS calls that anti-aligned, okay, but that just flips it around. And SOLIDWORKS tells me it changed the alignment, yeah, that's what I asked for. Okay, so now we can rotate that down, set that. So now, this arm is still free to rotate up and down, but I can't mess up its position. It's right where I want it to be. Okay, so let's bring in this next arm, arm 2, and I want to put this arm right down here connected to this end of the first arm. I could do it the same way by aligning the axis and then the face, or a little bit of a shortcut is I can accomplish that same thing by simply making that circular edge coincident with the corresponding edge of the arm 1. With that edge, okay, and that brings it down into position. Those are aligned correctly. Okay, so now this arm is also free to rotate, but it's going to stay attached to arm 1. Now let's do the same thing with this arm. I'll take that lower circular edge, made it to that lower circular edge of that receptacle. Okay, and it's free to pivot. Okay, so what I want now is 2 more copies of that arm. So how could I get 2 more copies of this arm?
Insert the same part.
Very good. I could go back to the insert component button and just bring it in just like I did the first time. Here's another shortcut. If you, I close out of the main box, if you hold down Control and click and drag a component, that will duplicate that component. Okay, so just hold down Control, click and drag, that makes another copy of the component. So you can very quickly bring in additional copies of any particular component just by holding down Control and then clicking and drag. So we'll make those 2 the same way. I want that circular edge to be mated with that circular edge of that arm, and that edge mate with that edge, and accept that. Now, the next component we want to bring in is the wheel. So I'll go back to Insert Components and browse to find the rover wheel, and I'll just drop that.